Hi, good morning. This is Srinivas Alwala, working as Assistant Professor in the Department of Computer Science and Engineering, SR Engineering College, Warangal, Telangana, India. Welcome to the presentation on virtual circuit networks. And before we move on to the presentation, let us know the course objectives. The course objectives are: students understand the virtual circuit network, understands how the packet transmits using a virtual circuit network in data communications. At the end of the course, the core outcomes are the students will able to know when a virtual circuit network is implemented and learns how the packets flow from the source to the destination using a virtual circuit networks, illustrates what kind of transmission is taking place in the network. Now let us see what is a virtual circuit network. A virtual circuit network is a cross between a circuit switch network and a datagram network. It has some characteristics of both. In the sense, the best characteristics from both the virtual circuit switch network and the datagram network are being combined together to form a virtual circuit network. As in a circuit switch network, there are setup and teardown phases in addition to the data transfer phase. Resources can be allocated during the setup phase as in circuit switch network, or on demand as in datagram network. As in datagram network, data are packetized and each packet carries an address in the header, but the addresses in the header has a local jurisdiction. It defines what should be the next switch and the channel on which the packet is being carried. All packets follow the same path established during the connection. A virtual circuit network is normally implemented in data link layer. Look at the picture here. A virtual circuit network, two end systems A and B, C, D, and a group of switches connected together, forming a virtual circuit network. And we see how the data is going to be transmitted by making use of a virtual circuit network. In a virtual circuit networks, the addressing takes a very important role. In a virtual circuit networks, two types of addressings are involved: global and local, where the local is called as virtual circuit identifier. The global addressing, a source or a destination needs to have a global address, an address that can be unique in the scope of the network or internationally if the network is a part of an international network. However, we'll see that a global address is virtual circuit networks is used only to create a virtual circuit identifier as discussed next. Virtual circuit identifier is actually used for data transfer. It is an identifier unique, unlike a global address, is a small number that has only switch scope. It is used by the frame between two switches. When a frame arrives at a switch, it has a VCI. When it leaves, it has a different VCI. When it arrives at the switch, it possesses a virtual circuit identifier, and when it leaves the same switch, it possesses another virtual circuit identifier. Virtual circuit identifier in a data frame changes from one switch to another switch. Note that a VCA does not need to be a large number, since each switch can use its own unique set of VCIs. Now looking at the setup request in a virtual circuit, where a setup need to be established, a setup request frame is sent from the source to the destination. Source A sends a setup frame to switch 1. Switch 1 receives the setup request frame. It knows that a frame going from A to B goes out through port 3. How the switch has obtained this information is a point. The switch in the setup phase acts as a packet switch. It has a routing table which is different from the switching table. For the moment, assume that it knows the output port. The switch creates an entry in its table for this virtual circuit, but it is only able to fill 3 of the 4 columns. The switch assigns the incoming port 1 and chooses an available incoming VCI 14 and the outgoing port 3. It does not yet know the outgoing virtual circuit identifier, that is VCI, which will be found during the acknowledgement step. The switch then forwards the frame through port 3 to switch 2. When it is forwarded to switch 2 receives the setup request frame. The same events happen here at switch 1. 3 columns of the table are completed. In this case, incoming port 1, incoming VCI and outgoing port. Then switch 3 receives the setup request frame. Again, 3 columns are completed. Incoming port 2, incoming VCI and outgoing port 3. Destination B receives the setup frame, and if it is ready to receive frames from A, it assigns a VCI to the incoming frames that come from A, in this case 77. This VCI lets the destination know that the frames come from A and not other sources. Acknowledgement. A special frame called the acknowledgement frame completes the entries in the switching tables. Now looking at the setup acknowledgement in the virtual circuit, the destination sends an acknowledgement switch to switch 3. The acknowledgement carries the global source and destination addresses, so the switch knows which entry in the table is to be completed. The frame also carries VCI 77 chosen by the destination as the incoming VCI for frames from A. Switch 3 uses this VCI to complete the outgoing VCI column for this entry. Note that 77 is the incoming VCI for destination B, but the outgoing VCI for switch 3. Switch 3 sends an acknowledgement to switch 2 that contains its incoming VCI in the table chosen in the previous step. Switch 2 uses this as the outgoing VCI in the table. Switch 2 sends an acknowledgement to switch 1 that contains its incoming VCI in the table chosen in the previous step. Switch 1 uses this as the outgoing VCI in the table. Finally, switch 1 sends an acknowledgement to the source A that contains its incoming VCI in the table chosen in the previous step. In virtual circuit switching, all the packets belonging to the same source and destination travel the same path, but the packets may arrive at the destination with the different delays if the resource allocation is on demand. Delay in a virtual circuit network. As we have seen in a circuit switch network, there will be a setup phase and a tear down phase and the data transmission phase. In a virtual circuit network, there is one-time delay for a setup and one-time delay for tear down if resources allocated during setup phase. There is no wait time for individual packets, as we see in the picture, shows the delay for a packet traveling through 2 switches in a circuit network. The packet is traveling through two switches, 2 routers. There are 3 transmission lines, 3 propagation times, data depicted by sloping lines, a setup delay which includes transmission and propagation in 2 directions, and a tear down delay which includes transmission and propagation. We ignore the processing time in each switch. The total delay equal to 3 transmission lines, 3 propagation times and setup delay plus tear down. Switching at the data link layer in a switched wide area networks is normally implemented by using virtual circuit tech.